Okay. We are doing question 3. We're on part what of the tool sheet? 3 part what?
Five.
Part 5, eh? Okay. So it said we prove this 22x being equal to 2 x over 1 minus tan squared x. So we started the proof by taking the left hand side. So we said we get tan 2x, which we managed to write in form of sine 2x over cos 2x, isn't it? And we know the identities we substituted for sine 2x, we had 2 sine x cos x. And then for cos 2x, we substituted cos squared x minus sine squared x. And then from this stage, we said we divide throughout by cos squared x. So we had 2 sine x cos x divided throughout by cos squared x, and cos squared x implies cos x. Then over, we have cos squared x divided by itself minus sine squared x divided by cos squared x. Okay, this is how far we went. Okay, so we proceeded further to simplifying this. For dividing throughout, we observe that this and this can divide, and so we remain with the sine x over cos x, which gives us tan x, isn't it? So we have 2 tan x over this stage. This divided by itself gives us a 1. Sine squared x divided by cos squared x gives us tan squared x. Here you have a 1, here you have tan squared x. So we have 1 minus tan squared x. So this gives us what we have on the right hand side. So hence the proof. Unless there are questions on this part, otherwise if there are no questions, we can go to the next screen. We go to part 5.
I haven't understood on the second from last part.
Pardon?
I haven't understood on the second from last part.
Is it this part or this part? This part?
Yes, that part.
Okay. So this part we said, when you reach this part here, you divide throughout by cos squared x. The area of interest is to have a 1 here on this part of the denominator time. You are comparing to what you have in the proof on the right hand side. You have a 1 here, right? We picked the left hand side and want to obtain the right hand side. So if you check on what you have on the right hand side, you have a 1 here. And now the only possible means you can obtain a 1 here is if you divide by cos squared x, because this divided by itself will give you a 1, isn't it? So now if you do that, so for you to obtain a 1 here, you divide throughout at this stage, you divide by cos squared x at this stage. Now, because you're dividing by cos squared x, to avoid changing the equation, you have to do this everywhere else. Even this part, you divide by cos squared x. That's the reason why cos squared x here. Here, cos squared x divided by itself, we have to do the same even here. We divide by cos squared x. So we are done with the denominator. Even on the numerator, we have to do the same. This is the numerator we had, this part here. We divide by cos squared x, the same thing here. And now this cos squared x, we are just to split it. We know that cos x by cos x gives us cos squared x. Right? So at this stage of the numerator, we are dividing by cos squared x. This is cos squared x, so that the two can divide out and remain with sin x over cos x, which gives us 1. Unmute yourself. Okay, should I repeat?
No, it's clear.
Sir.
Okay. So we can move to the next screen. So question 3, we're now on part 6. Want to prove sin 2x over 1 minus cos 2x, this being equal to cot x. So we prove this part. So to prove this part, we can take the left-hand side. Taking the left-hand side, we have sin 2x over 1 minus cos 2x, which is equal to, we can substitute some identity. Since we know the identity for sin 2x, we know the identity for sin 2x, and we know the identity for cos 2x sin. So for sin 2x, we know that it is 2 sin x cos x over 1 minus. And then for cos 2x, we also know this identity. You know this identity, it is cos squared x minus sin squared x. Cos squared x minus sin squared x. Okay. Then we can expand on the denominator. We expand here. That is, we distribute the minus throughout. So distributing this minus gives us 2 sin x cos x over 1 minus cos squared x. Then negative by negative gives us a positive. So we have plus sine squared x. Okay. Then we continue. We have 2 sine x cos x. Now observe that this is the sine squared x from the Pythagorean trigonometric identity. This is sine squared x. So we write sine squared x, then plus sine squared x, which reduces into 2 sine x cos x over 2 sine squared x. So the coefficients here will divide out. This will divide into that, isn't it? So we have this divides into that, so that we obtain sine x cos x over, and then is sine squared x, this part, sine squared x. Sine squared x is what to remain with. We can write this one as sine x, isn't it? So that we have this divided by itself. This divided by itself. And so we obtain cos x over sine x, which gives us cot x, and this is exactly what is equal, what is on the right hand side. That's the proof. So any question on this part? Okay, there are no question, wonderful. So we can proceed. We'll go to the next screen. Go to question 4. Question 4, part 1. So we've been given P sine x being equal to 4 and P cos x being equal to 4 root 3. The condition is that P is positive. P is greater than 0. So we find P and the smallest value of x. Okay. So let us find P. So from this, from P sine x being equal to 4, When you square on both sides, you have p from x, we square on both sides, which is equal to 4 squared. This gives us p squared sine squared x. Sine is equal to what? 16. Wonderful. From the other equation, we have p cos x being equal to 4 root 3. When you square on both sides, we have p cos x, then square outside 4 root 3 to square.
Sir,
Yes, please.
just there, why are we squaring? Can you please clarify on that one?
Okay. So the reason why we are squaring, we want to use the Pythagorean trigonometric identity, or we can do this. We want to use the Pythagorean trigonometric identity. We want to use this identity here. We want to use this identity, cos squared x plus sine squared x is equal to 1, isn't it? We want to use this identity. And we know that this gives us the radial sign, the equation of a circle. This is a unit circle. So we want to make use of this. Or we can do this, if this will confuse people. Allow me to use this approach. So we have p sine x being equal to 4. This implies that sine x is equal to what? 4 over what? Over p, isn't it? And also from the other one, p cos x is equal to 4 root 3. Making cos x the subject of the formula gives us 4 root 3 over pi. Now from the Pythagorean trigonometric identity, we know that when you square sine, sine squared x plus cos squared x, this gives us 1, right? Wonderful. So now we're going to square this. We're going to square on both sides. Squaring on both sides, so that we have what to put on sine squared x, sine, isn't it? Also we square on both sides for the cos part, so that we have what to put here. And so this gives us 4 over p squared, isn't it? That is squaring both sides here. Okay, before I write this part, others might not get it clearly. Let us do the squaring. When you square on both sides, we get sine squared x being equal to square on both this side of 16 over p squared, isn't it? Similarly, on the other part, when you square here, we square on both sides on this stage. So we obtain cos squared x is equals what? 16 by 3 over p squared, which reduces into what? 16 by 3. What is 16 by 3? 48. 48 over p squared. So now we have equation 1. and equation 2. So this is equation 1, and this is equation 2. So adding 1 and 2, adding 1 and 2, adding 1 and 2, what do you obtain? Adding 1 and 2 gives, so let us now add equation 1 and equation 2. So when you add the two, we know that this part is sine squared, isn't it? This part is cos squared x. So when we add the two, we have sine squared x plus cos squared x, isn't it? This is what we have. We are adding the two equations. On the other side, what is the sine squared x? It is 16 over p squared. And then what is cos squared x? It is 48 over p squared. Okay, so we proceed. So we have 16 over p squared plus 48 over p squared. And now on the left hand side, we know that this is equal to 1, isn't it? From the Pythagorean trigonometric identity, this is equal to 1. So we have a 1 here. We have a 1 equals 16 over p squared. So we can factor out something here. Okay, plus 48 over p squared. Okay, so this is what we have now. We have 16 over p squared plus 48 over p squared is equal to 1. Is it what we had on the previous screen? Yes, it is the 1. Equals 1. We can multiply throughout by p, isn't it? Multiplying throughout by p. When we multiply throughout by p, we obtain, okay, let us do that together. We have p squared we can factor out 1 over p squared, so that we have 16 plus 48 inside the bracket, being equal to 1. And so adding the two, 48 plus 16 gives us what? 64. Gives us 64 over p squared is equal to 1. And so we have p squared is equal to 64, isn't it? 64. Introducing square root on both sides and taking note that p is positive. We have p being equal to what? P being equal to root of 64. The positive root is 8, isn't it? So we have found the p. Any challenge or any question on this part?
Oh, sir, so they are the only aim for us just to find the value of p, right?
Yeah, it was just to find the value of p. So no wonder we were squaring. So we thought of squaring to be the easiest method. I know the other techniques that can be used. The other techniques that can be used here. One can begin squaring right at this point, and then they use the equation of the second. They begin squaring at this point. Okay, so we're targeting at finding the value of p first, before we find the value of x. So that's the reason why we squared on both sides. We had to make sin x the subject to the formula, then we square them both sides to obtain this. Equal from cos x. From the other part, we divide by p on both sides, since p is a constant time. So why are we dividing by p? So that we have the constants on the other side of the equal sign. This is a function, and this is a constant. Okay, so that squaring on both sides gives us this. So we obtain the two equations here. Now, when we add equation 1 and equation 2, it means we're adding sine squared x plus cos squared x on the left-hand side. At this stage, on the left, we have sine squared. At this stage, on the left, we have cos squared x. So when we add the two equations, it means we're adding what is on the left to give us this, and then we're also adding what is on the right to give us this, of which this we know it is 1. So that 1 here, so that we solve for p, and p is equal to 8. Any question? Okay, we can now find the value of x. We can find the value of x. So since p has been found, since p is 8, so we have sine x, which was equal to what? Is it 4 over p? Isn't it? 4 over p, and we know what p is, it's 8, we substitute. And so this gives us what? Half, fine. So we have sine x being equal to half. You can also use the one for cosine to find x, since the angle is just the same, in which case the angle is still x sine. So you can still use the one for cos, where the cos x is equal to 4 root 3 over pi. You can use that one to find x. But here we have decided to use sine. So we're getting sine x being equal to half. I know this is quite basic from this stage. To solve for x, introduce sine inverse on both sides. Sine inverse of sine x. You have sine inverse of half. You have introduced sine inverse on both sides. So this and this, the two are inverse of each other, we just remain with x. Wonderful. So we remain with x this side. And then on the right hand side, sine inverse of half is what? We know the acute angle here. Sine inverse of half gives us theta, gives us 30 degrees. So that's the required value. Any question on this part? Okay, well, no questions. Okay, so this will be almost cutting soon. I think for today, we can end here. Before I end the transmission, we can ask questions if at all you've got questions.
Yeah, so now how about when we just, since the values seem to be similar according to the equation given, why can't we just use 10? Because 10, of course, we'll be able to detect, the
Okay.
value of x, and P to find it very easy.
Okay, wonderful. So we can also try to use that idea. So where we have tan x is equal to sin x over cos x, isn't it? And this gives us 4 over p divided by what? 4 root 3 over p. So that we have 4 over p times p over 4 root 3, which gives us 1 over root 3. So we use this to find what? X, isn't it? I don't know whether you meant what I've done. Did you mean this?
I meant that. Yes, yes.
So we have tan x being equal to root 3, 1 over root 3, and of which you can find x, isn't it?
Yes, sir.
You can find x. So the procedure is just the same, isn't it? You can find x. So this one allows you to find x first. It allows you to find x first. Then when you find x, then you proceed in finding p. So this will also work. This will also work. Any other contributions or questions? So you observe that when you take inverse on both sides here, you have tan x being equal to 1 over root 3, so that you have tan inverse of tan x being equal to tan inverse of 1 over root 3, which gives us x being equal to 30 degrees. So you found x. Since you have found x, now you can find p. You can find p. So you have sin x is equal to 4 over p, and since x is 30, so you have sin 30 being equal to 4 over p. This is half being equal to 4 over p, which implies we've got p being equal to 2 times 4, isn't it? Which gives us p to be 8. Yeah, so we can also use this approach. Thank you very much. So any question on this approach?
Is this recording going to be shared in the groups?
Yes, I'm going to share the recordings as soon as I upload, and very soon I'll be uploading. So you'll see the link, then you'll be able to download the videos on YouTube.
All right, thank you.
Okay. So we end here until we meet next time.